Welcome to Siding Institute. We are going to do question 8, tutorial sheet 1, chemistry 1-1. The question reads, a 0.1 gram sample of nicotine. The formula has been given to be CHN with the coefficient here. We have X, Y, and Z to show the number of atoms of nitrogen respective to the what we have been given here. Then we have been given the molar mass of the same compound to be 162.26 gram per mole. As the composition of by masses, we have been given the mass of carbon, hydrogen, and nitrogen. Okay, so now the first question is to find the empirical formula. All right, so how are we going to find the empirical formula? I said we have been even given a record to say that find the empirical formula by first finding the value of X, Y, and Z. So we are just following that same procedure we were answering in question 7. So you can pause the video, you try to answer this, then you compare the answers. So to find the empirical formula, we do the same thing. Okay, our first thing is to find the empirical formula, the smallest formula. Okay, so what we are going to do now is to find the number of moles of both hydrogen. What have we been given? We've been given carbon. We're going to write carbon here. We say carbon. We have been given hydrogen. We have been given nitrogen. Okay, what have we been given? In the first place, we have been given the mass of carbon to be 0.07402. Then hydrogen have been given 0.008714. The nitrogen have been given 0.01727. All right. So these are masses. Now to find the first, we want to find the number of moles. We are going to divide by the number of because we know that the number of moles is given by mass over molar mass. So in our case, the molar mass, which is the atomic mass, since these are atoms, are not compounds. The atomic mass of carbon, when you go on your periodic table, it will be 12.01. Here we're going to have 1.008. Here we're going to have 14.01. We say 14.01 like this. Okay, so now once you divide, we're going to get here we have 0.00. Write the whole numbers as the calculator is giving without leaving any digit. Okay, like this. But for hydrogen, it's giving us 0.0086465. These are moles we are found. So these are number of moles, or we say moles here. Once we divide this, we are going to get 0.001233 moles. What are we going to do next now is to divide by the smallest value. Okay, we are going to see about the number of moles. Which one is the smallest? You can see that this one is the smallest, so we're going to divide both by this. Okay, divide here. We have a point here. Okay, we divide. As you can see, we are dividing by moles. That means moles will cancel. Moles are going to cancel out. Alright, so since here we are dividing the same number, we are going to have 1. Okay, we are going to get 1. Here, we are going to get 5. What is this? Compute well. For hydrogen, we are getting 7.013. Okay, which can be written as 7 because we just want a number, a single number. Okay, a whole number is what we want. Here we are going to get we are getting for carbon, we are getting 5. Okay, getting 5. 5.0. So our final step now is to just write the, what have we been given? I've been given carbon and nitrogen. Okay, so as you can see for carbon, this is our value of x. Okay, this is our value of x, which is 5. So we can even say, we can like to say that our x is 5, our y for hydrogen is 7, and our z is 1. So this is how you find this value. So we are going now to replace it. Where there was the x, we are going to put 5 here. Okay, we say 5, and here we have 7 for hydrogen. Then our nitrogen is 1. We can't write 1. It's the same as leaving it like that. Okay, so this is our what? Our empirical formula. So now, how are we going to find the molecular formula? It is very simple. Since we have been given the molar mass here, we are going first to find the number of moles using what? Using the empirical formula which we found. So let's go ahead and do this. Now, to calculate the molecular formula, this is what you are going to do. We just find the empirical formula, okay? Alright, so let me reduce the font. We just found the empirical formula to be, this is our empirical formula. Okay, this is our empirical formula. We're just from finding right now. Okay. So what we are going to do is to find the molar mass. Okay, the molar mass of this formula. To find the molar mass, we are going to add all the atomic what? The atomic masses. So for carbon we have 12.01 now times 5, since we have 5 here. So 5 multiplied by 12.01 plus hydrogen, we have 7 there, multiplied by 1.08. The nitrogen, since we just have one atom there, we're going to just add by 14.01. Okay, once you put that on your calculator, you're going to get 81, say 81.116 gram per watt per mole. Alright, so what are you going now to do next? After we find the molar mass of the empirical formula, then we have been given also the molar mass of what? Of the compound. What we are going to do now, we are going to find the number of moles. Okay, we are going to find the number of moles, which we can call the value of n. Okay, let's say that we are going to find the value of n, even if we don't call it to be the number of moles, because this is just now going to be the ratio of the empirical formula over the ratio of the molar mass of the compound which have been given over. So I can even say that the molar mass of a compound over the molar mass of what? Of the empirical formula which we just found. Okay. So the molar mass of a compound is this, is 162.26 okay, gram per mole. Alright. Over the empirical formula, the molar mass is 8.16 gram per mole. As you can see, gram per mole will cancel here. So dividing this, we are going to get the number of moles to be, which is actually 2. Alright. So now, since we have now the value of n, just follow these simple steps. To find out the molecular formula, you are going to say the molecular formula is equal to n multiplied by the empirical formula, which is n is 2. Our empirical formula is C587, then n like this. Okay, so our empirical formula 2C, we are going to say 2 times 5, we are going to have 10. Then 2 times 7, here we are going to have 14. Then n we have 1, we are going to have 2. So this is now our molecular formula. So this is how simple you go about finding the molecular formula. It is very simple. The first thing, you find the empirical formula. We have already been given the empirical formula we found on question 1. Then you find the molar mass of the empirical formula. Then you find the ratio of the molar mass of the compound to the what? To the molar mass of the empirical formula. After you find the value of n, you multiply by what? By the empirical formula. Very simple. So this is how simple you handle this kind of a question. If you find the video helpful, consider subscribing to the channel, like the video, also hit the notification button so that you may not miss out new uploaded videos. Thank you for watching. See you in the next video. We are going to answer question 9.